All right, in this video we will continue proving that triangles are congruent. We will take some baby steps in the direction of actual proofs, starting with these snippets, little pieces of a proof. So, looking at this segment, if we are given that B is the midpoint of AC, then that allows us to say that segment AB is congruent to segment BC. So segment AB is going to be congruent to segment BC, and the reason in the proof would be definition of midpoint. All right, sometimes students get this confused with definition of segment bisector, because a midpoint splits a segment into two equal parts, and a segment bisector splits a segment into two equal parts, so that's understandable. So how will you know when to use the definition of midpoint and when to use the definition of segment bisector? You will go by the wording. If you look at the previous statement, if you're given midpoint, then it's going to be definition of midpoint. If the previous statement had said, segment, something else, segment BF is the bisector of segment AC. If it said bisector, then it would be definition of segment bisector. Okay, BD bisects angle ADC. So here we have angle ADC, and so here's angle ADC, but BC is a bisector. BD is a bisector, which splits this into two congruent parts. And so we can now say that angle ADB is congruent to angle CDB. The order of these letters does not matter, as long as I put that D in the middle. I could have said BDA, or I could have said BDC, but those are congruent, and the reason is definition of angle bisector. Okay, so we're given these parallel lines, and parallel lines can lead to congruent angles. Sometimes it will be alternate interior angles, and sometimes it will be corresponding angles. And we like to say, look for either a Z or an F. So here's what I mean. Start by highlighting the parallel lines, though. So FE is parallel to BA. So here is FE, and here is BA. So those are the parallel lines. So now look for the transversal that cuts across them. So this is the transversal that cuts across both parallel lines. Okay, so this is not a very good F. It's facing backwards and everything's at an angle, but if you stretch your imagination, you can see this as like a backwards F. So when you see that F, the corners of the F are corresponding angles, which will be congruent since the lines are parallel. So we will say angle FEA, all right, angle FEA. By the way, you could have also called that angle FEC if you wanted to. Is congruent to angle BAC. Now these are corresponding angles, so the reason that we put when we come up with corresponding angles is the corresponding angles postulate. And normally I abbreviate this, but I think I'll write it out just to make sure everybody knows what I'm talking about. All right, corresponding angles postulate. Okay, now let's compare that with problem D. This time we're given that BD is parallel to AC. So let's highlight that. So I have BD right here, and that's parallel to AC. Okay, now I'm looking for the transversal, which in this case is going to be the diagonal that cuts across like this. Now, instead of forming an F, this forms an N, or you could look at it as a Z that's been turned on its side. When you see the N or the Z, you are looking at alternate interior angles in the corners. And those will be congruent on parallel lines. So we can call this angle DBC and angle ACB. Okay, so these are alternate interior angles. So when those turn up, the reason that you put is alternate interior angles theorem. And normally I would abbreviate this, but for the sake of the video, alternate interior angles theorem. Okay. And okay, looking at the rest of this snippet of a proof, I see that we have BC is congruent to BC, and of course that would be the reflexive property. Reflexive property. All right, it's not reflective, it's reflexive. Okay, C and E are right angles. Okay, so here is angle C and here's angle E. Those are right angles. When we are given right angles, we can say that they are congruent. So we can then say that angle C is congruent to angle E. And the reason is simply right angles are congruent. Okay. All right, now we're easing forward into proofs. All right, so now this is a full proof, but a lot of the statements and reasons are sort of filled in for us. Let's start with the given. B is the midpoint of AD. Okay, so if B is the midpoint of AD, then that means that DB is going to be congruent to BA. All right, so I've got that statement, but then that leads to the fact that DB is congruent to BA. And of course, the reason will be definition of midpoint, not segment bisector, midpoint. So definition of midpoint. Okay, on the last quiz we had in my class, for some reason, many students wanted to put definition of segment bisector right here. If this says midpoint, definition of midpoint. Okay, then we have the given that AD is perpendicular to BC. Okay, so that means this segment is perpendicular to this segment, which means that these are 90-degree angles right here. Okay? And that's what we write. When we have perpendicular, the next thing we say is, oh, look, this angle and this angle are right angles. So we will say angle, let's call it DBC. You know what? I better leave more space. It's kind of a little bit of a sentence. So I'm going to say angle DBC and angle ABC are right angles. Okay, and then that's because of the definition of perpendicular. All right? Oh, look, the previous statement said perpendicular, definition of perpendicular. That's very common. Okay, so that was it for the given. So next I see that they're saying angle DBC is congruent to angle ABC. Well, those are the right angles that we just mentioned. So now that we have mentioned that they are right angles, I can go ahead and say that they are congruent because we know that right angles are congruent. Right angles are congruent. Okay. So that's it for the given. We've done everything we can with the given. So far, I don't have enough information marked to prove that the triangles are congruent. But there's one more thing I can mark. The shared side is obviously going to be congruent for both triangles. So I will write that as CB is congruent to CB. All right, so CB is congruent to CB. And that is the reflexive property. All right, so now I can say that triangle DBC is congruent to triangle ABC. And it will be because of side, angle, side. Two sides, angle in the middle. That's side, angle, side. Okay. I'm just going to mark off to the side here that this is still problem number 5. All right. Just in case somebody's trying to skip ahead to this part of the video. Okay, so we have another little proof to do. Given BD and AE bisect. Whoa, this is blank. All right, man, we have to do this whole thing ourselves. Watch carefully. So BD and AE bisect each other. We're talking about this segment. All right, that's BD, and this segment, that's AE. They bisect each other. That means they cut each other in half. So first I need to write down that given as is. Okay, so you always, when it comes to the given, you're going to wind up writing down the given itself every single time. So we will first just copy this down. So we have BD and AE bisect each other. All right, and of course that is given. So bisecting each other means that they cut each other in half. So that leads us to the information that BC will be congruent to CD. So we will say BC is congruent to CD. Okay, and that will be the definition of segment bisector. All right, definition of segment bisector. Okay? Not the definition of midpoint. So when the previous statement says they bisect each other, then definition of segment bisector. Bisect, bisector. These go together. Midpoint goes with midpoint. Bisector goes with bisector. But they bisect each other. So also segment AC will be congruent to segment CE. So segment AC will also be congruent to segment CE for the same reason. So definition of segment bisector again. Okay. Well, that was the only given. So we've gotten everything we can out of the given. It's not quite enough to prove the triangles are congruent, but luckily we notice that there are some vertical angles here. And vertical angles are always congruent. Now on the last quiz, I had a few students still trying to say angle C is congruent to angle C. You can't do that. When you have two different angles, you have to use the three-letter name. So I'm going to have to say angle BCA is congruent to angle DCE. And that's because vertical angles are congruent. Okay. Now we have enough information to prove the triangles are congruent. So triangle ABC is congruent to triangle EDC by side angle side, of course. All right. Moving on to number 5, part C. We are given that angle B is congruent to angle E. So there's angle B congruent to angle E. Okay, might as well go ahead and write that down. So angle B is congruent to angle E, given. We are given that BC is congruent to EA. So let's see, BC is congruent to EA. Okay, BC is congruent to segment EA, given. And then they give us that angle C and angle DAE are right angles. So angle C and angle DAE are right angles. So we start, for starters, we just have to write that down. So angle C and angle DAE are right angles, given again. It's not enough to say that they are right angles. We need to say that they are congruent. So now that we've said that they are right angles, we can now say, okay, that means that angle C is congruent to angle DAE, because right angles are congruent. Okay. That gives us enough information to prove that the two triangles are congruent. So I noticed that we are not being asked to prove that the triangles are congruent. We're being asked to prove that these specific segments are congruent, but you still have to start by proving the triangles are congruent. So we're going to go ahead and say that triangle BCA is congruent to triangle EAD. All right, order matters. And that's going to be angle, side, angle. Now that the triangles are congruent, we can say that any remaining corresponding parts will be congruent. So now we can conclude that CA and AD are also congruent. Okay, so now we can go ahead and conclude that CA is congruent to AD because they are corresponding parts of congruent triangles. And we know that corresponding parts of congruent triangles are congruent, which we will abbreviate Cpctc. Please make sure that you know what each of these letters stand for. Okay, I'm just going to write it down one more time, Cpctc. If you think about it as the sentence that it is, it makes grammatical sense. Corresponding parts of congruent triangles are congruent. Okay, so this happens a bunch. Once you have proven the triangles are congruent, if there's an extra congruent statement that you need to make, the reason will almost always be Cpctc. Corresponding parts of congruent triangles are congruent. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.